Hello and welcome everyone. This is ECET Physics Sadhana, the next video lecture in the chapter Heat and Thermodynamics. Today's topic we are going to discuss about is the important questions and the PYQs from the topic first law of thermodynamics. Okay, already we have discussed many topics, started from the thermodynamic processes, then ideal gas, then perfect gas laws. Around 5 video lectures we have seen. This is the 6th video lecture in the continuation series of Physics Sadhana. Every day we are updating the content free of cost in our YouTube channel, so make sure you subscribe this channel and with consistency and discipline try to watch these video lectures up to the last and definitely note down all the important points and questions. Let's get started with the question number 1. The question number 1 given is, when a gas is applied dQ heat, it performs a work of dW, then the increase in its internal energy du is dash. Okay, it's asking about the equation. So okay, suppose this is a piston cylinder arrangement in which we are adding some heat energy to the gas molecules. Suppose when we are adding the heat energy to the gas molecules, then it should be the maximum value. Okay, then what happens, this piston is gonna move in the backward direction and creating some displacement. So force is getting applied over the piston due to that heat energy which we transfer to the gas molecules. When heat energy gets transferred to the gas molecules, molecules will have the random motion. They will start vibrating. Once this random motion is increasing, then the pressure force increases upon the piston and the piston moves in the backward direction, creating this displacement and work. Here work is given as dW, heat is given as dQ. But total amount of heat to work conversion is not possible because molecules are going to absorb some energy for themselves. That means molecule energy is internal energy du. So if you want to write this equation, then how it's going to look like, heat is what we are transferring and it is getting into what internal energy and work transfer. So finally we can add these two. That means heat energy is splitting into two energies, one is internal and one is work. Then what is the formula for internal energy gonna become? Internal energy is going to be written as d dash q minus d dash w or dw. So q minus w should be your answer. Q minus w, this is your answer. Go through it. And this is also called as differential equation of first law of thermodynamics. Go through it once. Pause the video, note it down. Let's move on to the next question now. The next question given over the board is, heat given to a system is 35 joules. Remember this sign conventions. Heat is given. Heat supplied. Heat gained. Heat added. Okay, these all are what positive heats. These all are taken as what positive. Similarly, when the question is given like this, negative heats, negative, that is heat is rejected, heat is lost, then you need to take the value of heat as negative. Similarly work, that is positive works, work of expansion, and work done by the system, positive. Then what about negative, sir? Negative works, work of compression, and work done on the system. These are going to be negative works. The question is very simple here. Heat given, that is positive. You know the formula, E dash Q, heat is equals to internal energy plus work energy. So heat is given, so heat is positive here, plus 35 is equals to du. Work done by the system is positive, that is 15 joules. 35 minus 15, du equal to 35 minus 15, 35 minus 15, 20 joules. So this is your final answer. Go through it. 20 joules is the correct answer. In this problem, sign conventions are very important. If he is going to ask you work done on the system, then it's going to be negative. Work compression, then it's going to become negative. Okay. Be careful with the signs. Differential equation of first law of thermodynamics. Already I have given you this statement. That is, when heat is given, that is Q, it is going to be splitting into internal energy plus responsible for doing the work. So dQ equal to du plus dW. This is the formula. Heat transfer is equals to change in internal energy plus work transfer. This is called as differential form of first law of thermodynamics. U plus W. U plus W. This is the correct answer. Okay. Moving on to the next question. Next question is again repeated question. The same question it is. Heat given to the system is 35. Same question, not even changing the values. Heat given is 35. Work done by the system is 15. Then internal energy change is equals to du is equals to 20 joules. Same question. Appeared in 2007 and 2013. Next question. A does 4.5 joules of external work during adiabatic expansion. It is an expansion process. Expansion means this is what a positive energy. Its temperature falls by 2 Kelvin. Temperature decreases. If temperature decreases, then internal energy also decreases. Then internal energy will be. It is talking about which process here? Adiabatic. Adiabatic, the process means heat is constant. That is heat transfer equal to 0. What is the first law of thermodynamics equation? Heat transfer equal to internal energy plus work transfer. Adiabatic. Adiabatic means heat transfer is 0. Then what will be the formula for change in internal energy? du. du equal to minus dw. du is equals to minus. Work value is given in the question as 4.5 joules. Negative indicates what? Decrease. Decreases. So decrease by how many joules? 4.5 joules. Very, very, very important question and expected question in the 2025. Remember this. Moving on to the next question. If the heat is added to the system, then it is utilized to. Heat is added. Heat is positive. Then it is utilized to what? Internal energy and work energy. This is change in internal energy. Change in internal energy. And as well as what? Work. Okay, change in internal energy and work done by it. Choose the correct option. Both A and B are correct. Both A and B are correct. Go through it. Let's move on to the next question now. The next question given over the board is heat of 1400 joules. Heat of 1400 joules is given. 1400 joules is given. Ideal gas at constant pressure, and the work done in expansion of its volume is 800 joules. Work done is 800 joules. Asked question is internal energy increases what? du is equals to 1400 minus 800. 1400 minus 800. Here 4, it's going to become how many joules? 600 joules. 600 joules is going to become the correct one. Just a substitution. Okay, moving on to the next question. System is provided with 200 calories of heat. 200 calories of heat. 200 calories of heat. And work done by the surrounding is 40 joules. Work done by the system on the surrounding, by the system. By the system is what? Positive. Okay. By the system is positive. What is that value? 40 joules. Now this value is in joules. This value must be in joules only. We know 1 calorie is equals to 4.2 joules. 4.2 joules. That means 200 calories is equals to 200 into 4.2. 2 zeros are 0, 2 zeros are 0, 2 twos are 4. 4 zeros are 0, 4 zeros are 0, 4 twos are 8, 0 0 4 8. Okay, there is 1 point, so this should be around 204 times 840, so this is going to become 840 joules. 840 joule is equals to du plus 40 joule. 40 joule coming to the left hand side, du is equals to 840 minus 40. 840 minus 40 is how many joules? 800 joules. It's a positive value. Positive value means it is increasing. Increasing. So increases by 800 joules. Go through it. Moving on to the next question. First law of thermodynamics is a special case of. We discussed that first law of thermodynamics is talking about heat energy is converting into what? Work energy. That means energy is converting from one form to another form. That means it is law of conservation of energy. Very simple, effective and important question. Law of conservation of energy. Remember it. First law of thermodynamics represents conservation of. Again repeated question. What is the answer? Energy. Again in 2024. Appeared to question 3 times. AP ECET and TS ECET. Moving on to the important questions now. In process of 500 calories of heat is given to a system, V dash Q is equals to du plus V dash W. 500 calories is given. Calories is given. 100 joules of work is done by the system. 100 joules. 100 joules. You know, in terms of calories, 1 calorie is equals to 4.2 joules. If you want to convert this in terms of calories, you need to divide it with what? 4.2, or you need to multiply this with what? 4.2 here. Okay, all the options are given in terms of calories, one option is given in terms of joules. Okay, what is the asked question now? Increase in the internal energy is. First of all, let me multiply this in terms of joules. Calories will be converted into joules. 500 into 4.2 times 500 into 4.2. 500 into 4.2. 4.2 into 5. Let's see. 5 2s are 10. 5 4s are 20. 21. Point is there, so this should be 21.0. So this is going to become what now? 2100 joules is equals to du plus 100 joules. 100 is going to be subtracted, and du is equals to how much now? 2000 joules. 2000 divided by 4.2 in terms of calories. 2000 divided by what? 4.2. So what is it going to look like? 4 1s are 4, 5s are right. Exactly value speaking, 476 is mentioning there. Nearmost value. Nearmost value 2100 minus 100. Work done by the system positive in the process of 500 calories given to a system, that is also positive. Okay, so that should be nearmost value. We know that 4 1s are 4, 500s are, but denominator increases, so overall value decreases. So this should be lesser than how much? 500. Lesser than 500 in the option, we can say the value is what? 476 calories. This should be the correct answer. Okay, go through it. 476 calories. Denominator increases, overall value decreases. So this should not be equal to 500, lesser than 500. Cross check, you can do it. 476 into 42. 2 6s are 12, 2 7s are 14, 15, 2 4s are 8, 9, 4 6s are 24, 7 4s are 28, 29, 30, 4 4s are 16, 17, 18, 19. This is 2, so this is 9, so this is 9, so this is 9, so this is 1. Okay, approximately speaking, if it is 4.2, this is 199.92. That is almost equal to what? 1000. So the correct answer is what? 476 calories. Important question, mark it. Moving on to the next question. In a thermodynamic process, pressure in a fixed mass of a gas is changed in such a manner that the gas releases 20 joules of heat and 8 joules of work is done on the gas. E dash Q is equals to du plus T dash W. In a thermodynamic process, pressure of a fixed mass of a gas is changed in such a manner that the gas releases 20 joules of heat. Gas releases 20 joules of heat, and 8 joules of work is done on the gas. 8 joules of work is done on the gas. If initial internal energy of the gas was 30, this is U2 minus U1, that is U2 minus U1 is 30. What will be the final internal energy? U2 is what? So this is minus 20, U2 minus 30 minus 8 minus 38, minus 38 going to the left hand side plus 38, 38 minus 20, 38 minus 20, it is 18 joules. So this is going to be the correct answer. Remember, work done on the gas is given, that means it is what? A negative work. Okay. Now gas releases 20 joules, that means it is rejected out. This is a rejection. Heat rejection it is. Heat rejection is positive or negative? It is negative. Initial internal energy, this is U1. Final internal energy, this is U2, where du is equals to U2 minus U1. Very important question. Go through it. So far not yet appeared, but yes, expected question in the ECET examination. Moving on to the next question. From what minimum height a block of ice has to be dropped in order that it may melt completely on hitting the ground, where L is the latent heat of ice and J is the joules constant. We know the formula W is equals to JH. According to the first law of thermodynamics, W and heat are proportional to each other. Proportionality sign conjugate but a constant. mgh is the energy because it is coming from a particular height. J, this heat is called as latent heat. Melting heat is latent heat. Latent heat formula H is equals to m into L, mass into L. So m into L, this mass gets cancelled. Question asked is what is the minimum height? H is asking. H is equals to JL divided by G. This should be answer. JL divided by G. Here is the answer. JL divided by G. You can ask you the value also. So value will be around some 34 kilometers. Okay, make sure you remember that and substitute it here. Okay, moving on to the next question. What an ideal diatomic gas is heated? When an ideal diatomic gas is heated at constant pressure, the fraction of heat energy supplied which increases the internal energy of the gas is fraction of the heat energy which is used for internal energy in constant pressure process. Okay, energy is converting into internal energy. Internal energy formula is mCV dt. This formula is constant pressure process, so mCp dt. Cv by Cp is called as 1 by gamma, where gamma is called as adiabatic index. There are three types of gases: monoatomic, diatomic, and polyatomic. And gamma values would be Cp by Cv. The values for the monoatomic is equals to 5 by 3, this is 7 by 5, this is 4 by 3. This value would be 5 by 3, that is 1.66, right? 5 divided by 3, 3 ones are 3, remaining is what? 2. So 20, 3 6 are 18, goes on. So it is 1.66. This value is 7 by 5, 7 divided by 5, 5 ones are 5, remaining 2.0. 5 4s are 20. So this value is exactly 1.4. 4 by 3, 4 divided by 3, 3 ones are 3, remaining is 1.0. 3 3s are 9, remaining 1, 3 3s are 9, goes on. This is 1.33. Asked question is for which type of gas? Diatomic gas. Diatomic gas gamma value is 7 by 5. 7 by 5. Here we require 1 by gamma, that is 1 by 7 by 5. 7 by 5 reciprocal 5 by 7. This is going to become your correct answer. Go through it. Similar question already we have seen. Now the last question over the board is heat added to a system is equal to. Heat added is equals to dash Q is equals to. This is called as what? non-flow energy equation. Non-flow energy equation. Okay. So here we are having the piston cylinder arrangement. In the piston cylinder arrangement, we are having gas molecules. This molecule is having some potential energy. This molecule is having some kinetic energy and possess some internal energy U. Now we are supplying the heat energy to it. Okay. Then what happens when you supply the heat energy? Finally, they are going to be having what? Work energy. Now internal energy is going to become U2. Velocity will become V2. Okay. And potential energy will become some H2 or Z2 we can say. Okay, potential energy H2. Let me write here Z2 because H is usually height, so Z2. So initially they are having what? Z1, V1, U1, Q1 to 2. Now we are having W. So let me write all the energy equations. Initially they are having what? Heat energy, some internal energy, some kinetic energy, some potential energy. When you supply the heat energy, they will be converting it into what? Work energy, final internal energy, final kinetic energy, final potential energy. Okay. So when you heat is added to the system, change in internal kinetic energy is changing from V1 to V2 or not? Yes, correct. Change in potential energy mgh, mgz is changing from gz1 to gz2 or not? Yes, it's changing. Work done by it, heat is converting into work. Yes, sum of all the above. Yes, sum of all the above is the correct answer. Okay. Potential energy changes, kinetic energy changes, and heat is converting into work energy. This is one of the important question for the ECET examination. Go through it. So, pause the video, note it down. Don't forget to subscribe the channel and press the bell icon to be notified for every update from the SAIMEDHA, Hyderabad. Every day we are adding some educational content free of cost in a YouTube channel. The playlist name is Physics Sadhana. Already many videos has been updated. This is the chapter Heat and Thermodynamics. Topic is first law of thermodynamics. Okay, with such educational content I'll come back one more time. Till then, keep learning with SAIMEDHA.in. I wish you all the best.